Hello and welcome. This is Camille Fairborn from Michigan State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. We're pleased to have as our presenter today Dr. Rochelle Tractenberg, who is a full professor in the Department of Neurology at Georgetown University and is currently the chair of the ASA Committee on Professional Ethics. For today's webinar, she will give a presentation entitled The Hows and Whys of Reasoning with the ASA Ethical Guidelines. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box. We'll be sure to ask those questions towards the end and give the presenter a chance to respond. You can also use the chat box if you're having any technical questions, and I'll try to address those behind the scenes. At this point, I'll turn things over to Dr. Tractenberg. Rochelle, go ahead.
Thanks very much. Can you hear me? Is this working?
Yep, we're good. Go ahead.
Okay, great. Thanks so much. So I am the current chair of the American Statistical Association Committee on Professional Ethics, and I started that January of this year. Prior to that, I was the vice chair of this committee, and I was the chair of the working group on the revisions of the guidelines, which were, these revisions were approved by the board in 2016, May of 2016, and the prior revisions were in 1995. So they've been recently sort of updated, modernized, and revised. So today, briefly, I'm going to be talking about the guidelines, and these slides have the URL where you can go to the ASA website, or you can Google ASA Ethical Guidelines. I would add statistics in that if you do a Google search, because you're going to get the American Society for Anesthesiology and also the American Sociology Association guidelines as well. There will be a little bit about why you should know about the guidelines, particularly if you are teaching introductory statistics to non-statisticians, people outside the major. And then most of our time is going to be talking about how you can use the guidelines specifically, because knowing that they exist or knowing where they are is not enough, and ethical reasoning is a learnable, improvable skill set that you can use to enhance the guidelines' relevance and applicability to your work and potential problems that you may encounter while you are doing that work. So I'll go through ethical reasoning, and specifically two of the steps in the ethical reasoning methodology that tend to be the most difficult, sort of just as barriers to start working through a challenge that may arise. So as I mentioned, in 2016, the ASA board approved the current revisions to the ethical guidelines for statistical practice. And in the preamble, we were specific about what are the purpose of these guidelines. They exist to help statistics practitioners make and communicate decisions ethically. These decisions relate to choices that we make, assumptions that we make when we engage in statistical practice or analysis. And you can imagine that if you're a professional statistician, this is relevant, but it's actually also really important for people who are just doing the analysis for their own, master's thesis or undergraduate thesis, or if you are the most quantitatively oriented person in your research group or business team, you're the statistician of record according to the ethical guidelines. So these guidelines exist to help any person who is engaged in statistical analysis to both make decisions ethically and communicate those decisions thoroughly and ethically. Also, they exist to inform those who rely on these analyses, including employers or colleagues or the public, of the standards that they should expect. So by sharing them more widely with undergraduates who may or may not go on to become statisticians themselves, it's really important to give people the idea that there are standards of practice, and these should be upheld. They should be looked for, whether you're the statistician, whether you're on a team of statisticians, or whether you're a person who is employed or is working with a statistician. It's really important to appreciate the fact that for the profession, the fact that we have these guidelines does go some distance to reinforcing the value that we as a profession place on trust, that we recognize that people trust us, but also that we understand that statistical practice involves sort of perspectives from other disciplines as well. So understanding that the guidelines exist and using them, it's really important for the profession as a whole to make sure that not only do we say, hey, we have these guidelines, but also know what they are and how they can be used so that, in fact, they do offer guidance. And as I mentioned, specifically in the guidelines, we articulate that they exist to guide both those whose primary occupation is statistics and those in all of the disciplines who use statistical methods in their professional work. It's really a very important attribute the Committee on Professional Ethics and the Working Group on the Revision of the Professional Ethics Guidelines felt was extremely important, that these are explicitly made relevant to people who may not self-identify as statisticians, but who are engaged in statistical work in the course of their day. From the undergraduate instruction perspective, the guidelines can be used to promote professionalism in those who will then go on to become professional statisticians. But the idea that undergraduates are being prepared for any profession, there is a sense in which they need to develop some sense of professional identity, and seeing that even though you're just doing a t-test on a homework problem or whatever, that could lead to this sort of identity, a professional identity, and particularly with respect to the quantitative disciplines. So they're really important from a lot of different perspectives and at a lot of different points in the undergraduate and into the graduate development. So the guidelines themselves, the URL is at the bottom of this slide. They comprise 8 overall principles, and among those principles there are 49 specific elements. Now, I've listed the principles here, and in parentheses, the number of specific elements that each of these principles has. So the principle of professional integrity and accountability outlines different features of or manifestations of the professional statistician's accountability and integrity, and similarly for the integrity of data and methods. So there are a different number of elements for each principle. It's really important to note that there are 49 different elements, and knowing that there are 49 or knowing what they are isn't the end of your responsibility as a statistician to knowing about and utilizing the guidelines. Just memorizing these rules isn't enough to make sure that they can be useful and are used. So that's why in my prior research in 2012, I published a paper on ethical reasoning rather than training in sort of factual memorization in the responsible conduct of research. But ethical reasoning is a series of steps that one can learn and improve one's ability to step through, so that when an ethical challenge arises, the decision that must be made to address that ethical challenge can actually be made and justified and then defended and reflected on. So specifically, when there is a challenge, you have to sort of take a moment and determine whether or not you have sufficient prerequisite knowledge to recognize the extent of the ethical issue, but also deal with the issue. So the first step is sort of to identify your prerequisite knowledge and determine whether or not you need to stop here. You don't have enough prerequisite knowledge, say, about the guidelines. You need help, and then to seek help. Maybe you don't remember if there is a guideline principle that is relevant in this case. For example, one that talks about research subjects, or one that talks about conflicts of interest. So identifying your prerequisite knowledge is the first step. Second step is to recognize the ethical issue that exists, and specifically that a decision must be made and what that decision is. That's one of the more difficult features of ethical reasoning, so we're going to be focusing on that for a couple slides. Then identifying relevant decision-making frameworks. This is challenging, but once the ethical issue has been identified, relevant decision-making frameworks like utilitarianism, making a decision that favors the outcome that has the greatest good or does the least harm, the identification is less difficult than recognizing the ethical issue itself. And identifying and evaluating alternative actions given that framework. For example, if you choose utilitarian or if you choose a virtue ethics model, identifying and evaluating alternative actions is actually the other very difficult step in the ethical reasoning process. Once you recognize the ethical issue and identify the alternative actions, then you have to make your decision. You're going to choose one of those alternatives and justify it. Then the last step is to reflect on the decision to see whether or not something could have been done to prevent it originally, what can be done to prevent it in the future. So these are the steps of ethical reasoning that's based on sort of a consensus in ethics around what people need to do when they encounter ethical challenges. So that's not new. What's new is the identification of this set of steps as both learnable and improvable. That was in the 2012 paper that I mentioned earlier. In this 2016 paper that's cited here, and there's a page with references on it, this paper was published in the proceedings of JSM 2016, walks through these steps for ethical reasoning in a couple of very simplistic, but actually based on real experience cases. So this table should be in the appendix. The slides that I sent that you'll be able to download from the website, this is in the appendix. This is just an example. The ethical reasoning steps I just described are across the top row. Identify prerequisite knowledge, recognize the ethical issue, identify relevant decision-making frameworks. That's across the top. And what this and the next table show is that you have, for each of the ethical reasoning steps, you can apply each one to each of the key principles in the ethical guidelines. The first one being professional integrity and accountability, that's principle A. So the in the 2016 paper, it discusses at length how to build up the ability to walk through these ethical reasoning steps for each of the guidelines. I want to pause here momentarily to point out that the actual engagement of ethical reasoning steps in your use or development of an understanding of the guidelines, you can see from this table, is quite complex. Knowing what the guidelines are isn't sufficient. For example, to engage in ethical reasoning, the level of professional knowledge or training that you have has to be sufficient in order to identify the ethical issue. And if you're not sure, you should recognize that you're not sure, recognize that you need help, and then actually ask for help. Asking for help is in itself a challenge because you may or may not have access to an ombudsman or ethics consultation at your institution. So these are just knowing that you have obligations to maintain and exercise your professional integrity may not be sufficient to really use the guidelines. Then principle B relates to the integrity of data and methods. So this table, and in the paper, this table appears and is discussed at length in the table. In the paper, talks about walking through the same ethical reasoning steps across the top for principle B relating to integrity and data methods. Recognizing that the ethical decision exists and must be made is the first sort of barrier. It's sort of the first problem that people have. So that's why we're going to focus on what does it mean to recognize that an ethical issue is before you. And in this case, this is from the Gunaratna and Tractenberg 2016 proceedings paper. You can see that the case is simply that you are an analyst of whatever level, professional or casual, and you have a client or a collaborator who either doesn't know how to present correct, transparent interpretation of results or is not committed to presenting correct and transparent interpretation of results. This could be a person who insists on cherry picking, or a person who simply doesn't understand that, showing only the p-value that is less than 0.05, that of course that's what people want to do. Why don't you want to do that? You are impeding me. That collaborator might say something like that. Recognizing that that's actually an ethical challenge to the statistician is really important. Another important thing about this recognition is this guideline, or sorry, this challenge, this ethical issue, doesn't arise from something that the statistician does. It arises from something that someone else does, but the statistician must respond. So in this case, recognizing the issue, if you're not sure what it is, you kind of think something's going on. This person wants to cherry pick, but I'm not really sure what the ethical issue is here. You can use the guidelines to find out what it is. So that's what this table is doing. The case is someone doesn't want to present transparent interpretation of the results that you've generated. So we can look at the different guideline principles, which is the first column, and see whether or not that principle helps us to identify the challenge or the decision to be made. In this example, maintaining professional integrity, or your obligation to maintain professional integrity and accountability, and to preserve and insist on integrity of data and methods, they do not inform us about whether or not there's an ethical issue. So we can't use either of those. But when we come to responsibilities to science, the public, the funder, or the client, we do actually find that there are some bits of this ASA guideline principle that can help us to identify and articulate what the ethical challenge is. Specifically, the analyst has obligations to science, or the public, or the funder, or the client, to ensure that everyone, the client, uses their results responsibly. That's actually the statistician's responsibility. So there's an ethical challenge right there that was identified by walking through the ASA guideline principles until you get to item C. In this particular case, the data were already collected, so item D, principle D in the ASA guidelines, doesn't help us identify any challenges, but responsibilities to research team colleagues does. The analyst has obligations to all members of the research team to ensure that the collaborator or client uses their results responsibly. So this is just an example of using ethical reasoning and the guideline principles together, and not simply knowing the guideline principles, which are listed here, or their constituent elements, to identify what the actual ethical guideline, the ethical challenge is. But that's only the first step, and as I mentioned, this is a difficult step to engage in. So that's why this paper, the 2016 paper, walks through ethical reasoning and the guideline principles and using them together. Importantly, looking through the guideline principles in this way in order to identify what the ethical challenge is also potentially raises or identifies some solutions. So, for example, Principle F, responsibilities to other statisticians or statistics practitioners, offers a potential solution. This guideline principle can be used to help encourage the collaborator by saying, you know, you're not going to find another statistician who will cherry pick for you. We are all sort of engaged in ethical statistics. So it's really important that you don't just, you know, leave my office and go down the hall and try to find somebody who will cherry pick for you. Similarly, Principle H, responsibilities of employers, it offers a potential solution. You can point to this particular guideline principle to explain to the client, you're responsible for maintaining a moral climate for me to do my work in, and I can't do that when you are asking me or insisting that I cherry pick. So this is just an example of how recognizing the issue, which is tends to be very difficult in terms of ethical reasoning, can also lead to potential solutions. So in this case, just revisiting this actual case and how it can help us to identify ethical issues, we have a collaborator who is either not able to or is not committed to the results being presented in a correct and transparent way. Again, I want to point out that the ethical challenge here for the analyst comes from something that another person is doing. You have to make a decision when you're faced with people who want you to do things that are not specifically sanctioned or ethical. The guidelines are sometimes not about your ethical practice. They're about how you react to others in an ethical way. So the second step in the ethical reasoning process that tends to be difficult is to understand what the alternatives are. As I mentioned earlier, there's an intermediate step here, which is to identify a decision-making framework that you can use, like utilitarianism or virtue ethics. A virtue ethics perspective is when you choose an icon or someone or some characteristic that you strive for. You want to be the best statistician you could possibly be. What would that person do? So we've skipped that so that we can focus specifically on what are plausible alternatives anyway. Well, the first and very frequent option when faced with an ethical challenge is to do nothing. You don't know what to do. You're not really sure about what the ethical decision is or even what the ethical challenge is. So you just do nothing, wait or see what happens. That is an actual alternative action, a decision that you can take. Or you can engage a colleague to either help you identify what the ethical challenge is or to formulate a response. Or you can report that person. This person's trying to coerce me into cherry picking. I won't do it. I will tell my boss or the ombudsman or the funder. So those are three plausible alternative actions of what a person can do when faced with a person who wants you to cherry pick data. They're they're plausible, but they're not really very complex. But the point of this exercise is to just see that the guidelines are informative with respect to the alternatives as well as with respect to the identification of the ethical issue. So in this case, you again walk through each guideline principle and look at the three options that you've identified. Do nothing. This alternative is not consistent with principle A, but principle B is not informative about whether or not any of these principles, including doing nothing, is a good idea or not. It turns out that engaging a colleague and reporting the client, engaging a colleague is consistent with principle A, but reporting the client, there's no information about what you should do, about whether you should report the client coming from principles A and B. Specifically, you can see you have responsibilities to science, the public, the funder, and the client. Doing nothing is not consistent with principle C. Engaging a colleague is consistent with principle C. And it's possible that reporting the person who wants you to cherry pick is consistent with principle C, but you are responsible to both the public and the client, or to science if you're generating scientific results, and the client. So you have a conflict there. And going back to the previous step that we haven't talked about, that's when that might come into play, where you would say, if I prioritize science or the public over the client, is that doing more good or more harm? So the decision-making framework may be more relevant there. Again, pointing out the fact that knowing what the principles are isn't enough. It can't, just knowing what the principles are can't help you decide what to do or justify or choose from among options when you're faced with options and alternative actions. Responsibilities to research subjects is importantly not informative about these subjects, about these potential alternatives, because if you do nothing when there's an ethical challenge, you may be biased against the research subjects just because doing nothing prevents them from finding out that something wrong was going on or something was amiss. So doing nothing is never consistent with any of the ASA guideline principles. Even though it's common and simple, it isn't consistent with guideline principles. And doing nothing is a decision. It's not actually an action, but you do have to decide not to take action. And it is inconsistent with every ethical guideline principle, except for the ones that are uninformative, like integrity of the data. These other alternatives, as I mentioned, they're generic, but the point here is that they can be evaluated. And this step in the ethical reasoning process is to both identify alternatives and evaluate them. So you can see that talking to a colleague is much less sort of aggressive, than reporting the client. So you may not know for sure if the person is really coercing you or committing fraud or whatever it is. So rather than go that sort of full bore, you can engage a colleague. Maybe your colleague's advice will be to report that person. But the point here is that these are a valuable alternative. It's really important to recognize when you have alternatives that you can evaluate. And if you were engaged in these ethical reasoning steps in a more formal way, which you would only be if you learned how to do that and were given practice in a concrete and explicit way, you would be able to come up with much better specific alternatives than the ones that I have come up with, which, as I mentioned, are generic, but at least they're valuable. And if you were faced with this sort of situation, or you were leading a discussion in your classroom about this sort of situation, you could encourage the students to think about more specific alternatives than these. They're generic and valuable, and maybe part of your evaluation of them in a classroom would be, is this really plausible? Do we need more information? Which again goes back to the first step in the ethical reasoning sequence, which is to determine whether or not you have enough information to make a decision. So in the paper, there's a second case where you have a client or collaborator who is not aware of statistical concepts like sampling bias, and that person also has not identified confounders, but the data have already been collected and you have already committed to planning and executing the analyses. So here you are trying to plan a correct and complete analysis. You are trying to follow principles A and B, but you're being prevented either by a lack of awareness or an explicit awareness of those things, but the knowledge that they may prevent the desired result from coming about. You again have these three actions presented as generic but valuable alternatives that you can then evaluate. This paper has the tables filled out, and the paper with these two cases can be used in a classroom situation to sort of walk through ethical reasoning. You can do the same thing that is structured in these tables with other cases that you may come across. So basically, this is my last slide apart from the references. The ethical guidelines for statistical practice are designed to help you be a more professional practitioner if that's what you are, but they're also there to help you whether or not you're trained as a statistician, if you just happen to have done an analysis for someone, and to appreciate the fact that there are very serious consequences to prevention. If someone prevents you from doing your job in an ethical or professional manner, there will be ramifications. And that is, in principle H, that is something that statisticians should be protected from. These guidelines represent the habits of mind that characterize the experienced quantitative practitioner. They were created by a team of highly experienced statisticians from around the statistics domain, data science, government, industry, and academia, and they can be used to promote professionalism in the statisticians that we are training, as well as the development of professional identity. And the 2016 paper outlines ethical reasoning. This can be used both for instructors who want to create coursework or experiences or discussions in their classes to introduce the guidelines, introduce and provide practice with ethical reasoning, and teach sort of students how to recognize and then deal with challenges that may come up. But they are also useful for individuals who may be self-directed or who want to build experience with the guidelines or evidence of their engagement with the guidelines. So some of the references are here. This slide is not an exact match to the one that is available on the CAUS website because the Ethical Guidelines for Statistical Practice has a URL there. But I'll stop here and take any questions.
All right, thank you so much for this presentation. If you have questions that you'd like to ask Dr. Tractenberg, go ahead and type them into the question box and I'll ask them to her. While people are thinking about that, I have a question for you. Do you see this 2016 paper as something that would be appropriate for even like introductory first-year stats students to read and engage with?
Yeah, absolutely. And the 2016 paper really focuses on the paradigm of ethical reasoning as something that can be taught, something that's teachable. I mean, all of these things are learnable and improvable. That's sort of a focus of the work that I've been doing for education generally. But in the 2016 paper, we really talk about teaching with these ethical reasoning steps by identifying what are the hardest ones and trying to help people to see that they're sort of iterative. So that paper can be used and reused. And all of these papers here on the reference page talk about what does it look like to change over time in your ability to reason ethically. And the 2015 paper that was in Science and Engineering Ethics has 2 syllabi. One is for the ethics guidelines for the Association of Computing Machinery, and one is for the ASA Ethical Guidelines. Both of those syllabi could be they could be a full semester course for either graduate students or undergraduates. And the important thing is that you can look at the same case every year and expect that the student would demonstrate more sophistication in their reasoning each time they encounter the case. So you could come up with new cases every time, but it may be useful to revisit the same cases periodically or, over time, so that you give people the chance to sort of elaborate on what they thought or wrote or reflected on, what they decided before. What would they do now, and why would they do something differently now if they change what they would do?
That's very interesting. Thank you. We have another question from Beth Benzing. She says, could you provide a specific example to what you refer to as cherry picking?
Oh, sure. So unfortunately, the Nalupa and I, when we were writing this paper, we were both thinking about multiple examples of each of the cases. So the cases that we put in this paper are just really, really pared down generic representations. But I just finished a project, and by finished, I mean withdrew because the person was coercing me to cherry pick, because I did a full program evaluation, so I had all the results, and they only wanted me to specifically report the positive results and not mention the negative results. That was more of a qualitative analysis, but I had another individual probably 10 years ago who was convinced that his intervention had an effect. It had an effect on 1 out of 24 items of a survey or of an instrument, and he only wanted to report that one item and not any of the other items. So I said, of course, no, and you can't do that, and I explained why. But he insisted and repeatedly only focused on that one important outcome and never mentioned the other one. So I withdrew from that project as well. Does that answer your question?
Well, I think so. And do you see withdrawing as a viable choice in these ethical things? Does that provide the kind of outcomes that we want to see?
I think I'm really, really glad you asked that question, because as you mentioned, I am a full professor. I have tenure. If I withdraw from a program like I did last month, I was getting salary support. This is a federal, a funded grant, and I withdrew. And you cannot punish me for doing that because I'm not junior. But 20 years ago when I was just starting out, I would not have been able to withdraw. So it's really, really important for people to have alternatives besides withdrawing. At this point in my life, I just don't want to bother arguing with people who are also advanced, also have tenure. They can't be punished for fraud, really, unless I did something much more aggressive than just removing myself. But the point is that if you withdraw, you send a signal, and that person may or may not engage in that same behavior, when I withdrew 10 years ago, that person did sort of eventually get a message that only reporting that one item isn't useful. I think that me withdrawing from that project helped other people to say, yeah, I actually need to see the rest of the data. So in a sense, you can say, hey, person, stop asking me to cherry pick. And if they don't respond to that, you can say, I can't cherry pick. That's just not consistent with the ethical guidelines for my profession. So I have to withdraw. Or, you know, so there are a lot of options, but the earlier in your career you are, you don't have those options. So when we were revising the guidelines, I tried to be really specific about how a person who is junior could use them to go to their boss or somebody more senior and say, here in the guidelines, it says I shouldn't cherry pick. And I'm sure you're not asking me to cherry pick because, you know, that's against the law. But can you help me fill your request without violating this document that actually guides my profession? So it's a really, really important question. Withdrawing is sort of a last resort. But if it's only a last resort if it's actually an option for you.
That's insightful. Thank you. John McKenzie's asking, could you please comment on fake data?
So fake data, fraud, falsification, and plagiarism are illegal. If you do this in the context of an NSF grant, you'll be disbarred and you will never be eligible for NSF grants again. But if you do it in the context of an NIH grant, you will be eligible after 3 years, providing you are caught. So fake data or faking data or reusing data that are not relevant in papers, those are grounds for withdrawal, but you have to be caught in order for those to be, problematic. That's one of the reasons why it's so important to point these guidelines out to anyone who may be charged with analyzing data at any point. It's really important to integrate these into undergraduate training. The fact that something is illegal or some grounds for disbarring clearly isn't sufficient to counter the pressure that people feel to succeed or get papers published or have surprising results. So I think that, on the one hand, of course, fake data, don't fake your data. Come on, you're lying. I mean, it's just it doesn't have to be in the guidelines to be obviously wrong. The question isn't, is it wrong or how do we get people to recognize that it's wrong? The question is really, how do we ensure that people understand that it's okay for your analysis to show no result? Uncertainty means you don't know how it's going to turn out. If you expect it to turn out with yes, p less than 0.05, and it doesn't, you've created a problem that didn't need to be created. So I don't know if I'm answering your question, but there are two groups of people who are going to be reading or exposed to these guidelines. One group of people for whom it does not matter. They'll do anything to get published or whatever they're trying to do with the data. Showing them the guidelines or withdrawing from the project won't help. And the other group are people who don't realize that it is okay if your study didn't turn out the way you thought. That's a result. And you need to sort of do sensitivity analyses, and there are alternative ways to be more certain about the fact that you had a null result. I hope that's helpful.
That is, thank you. We have one more. It says, in addition to cherry picking and faking data, what sort of examples of ethical dilemmas have you used in your teaching?
Well, I think that the real challenge is in when a person like me, so I come from a social science background. I have a PhD in cognitive science, so I'm an experimental psychologist by training and also a statistician by training. So all of the things that I do, the decisions are really crucially dependent on the data and the quality of the data. And that's sort of how my training was developed. But when I work with somebody who does not come from that background, they really don't see why we should report all of our results of all of our analyses, or correct for multiple comparisons. So multiple comparisons is actually one of the biggest problems that I find as a reviewer and as a collaborator, that people will say, if I correct for all the comparisons I did, then the thing I found will disappear. And that, so again, sort of giving the analyst permission to come up with a real result, that's a really important and powerful role that the statistician has. So that's just something that is very common, that it's a little bit different from cherry picking, but you know, technically it's the same thing. But instead of talking about resisting cherry picking or withdrawing from a context where you're being asked or required to cherry pick, it's also possible for the statistician to say, you know, if we did a couple more sensitivity analyses, this could be a really powerful negative result paper. And I will lead that effort. I will write the paper that describes why this experiment did not find the expected result, because they never corrected for multiple comparisons in previous studies. But if they had, no one would ever be talking about that outcome or whatever it is. So there's the idea that multiple comparison corrections are essential, but also the idea that negative results can also be super informative for science, for the community. And I hope that's a helpful answer.
That is, and it's part of what I think all of us need to do as educators. Thank you again, everyone, for attending today. As a reminder, we do have a second teaching and learning webinar scheduled this week on Thursday at 2 p.m. Eastern Time, where Kevin Ross and Dennis Sun will demonstrate their Python package called Simulate, which they developed to conduct simulations involving probability models. We also have a full slate of additional webinars scheduled in the coming months, so I encourage you to keep an eye on your email or the causeweb.org website for those announcements. Thank you again, Dr. Tractenberg, for being here today, and for all of you who attended, and I hope you have a great day.
Thank you.